This brings me to the last question. Can particles think? And you won't be surprised to hear that I think the answer is no. So again, I first have to explain why would someone have this idea to begin with. So this, I have to say, is maybe not so surprisingly not an idea that's particularly popular among particle physicists. It enjoys a certain popularity among philosophers. So they have this idea of panpsychism. Everything is a little bit conscious. Because it contains something that they call proto-consciousness. And the idea is that it explains where consciousness comes from, because you can combine all those little bits, very much like particle physics, and they form bigger things like us. And at some point, the proto-consciousness combines to what we normally call consciousness. Now, there are different variants of this argument. One is that this proto-consciousness isn't a physically real thing. So this is very much like dualism, and it doesn't have any observable consequences. So just like you can say, well, the mind and the body is really two separate things, and this is fine, it's not in conflict with science. This idea of proto-consciousness without observable consequences is also not in conflict with science, but then, of course, you can't use it to actually explain what we observe, because it doesn't have any observable consequences. So that's really, I would say, a purely philosophical thing. But there are also some of those panpsychists, or whatever you want to call them, who think that this consciousness stuff is actually physically real. So they want to actually use it to explain consciousness in the old-fashioned scientific way. Now, the problem is that what you're doing then, if you're talking about the properties of the fundamental constituents of nature, you're actually doing physics. And then your talk about proto-consciousness better agrees with what we know about the fundamental laws of nature. So I have to look at this in a little bit more detail. This is what we know about the fundamental particles in the world. This is basically what everything is made of. Called the Standard Model of Particle Physics. You don't have to count them, there are 25 of them. Contains good old friends like the electron, and the photon, and the Higgs boson. The Standard Model of Particle Physics does not contain composite particles like protons and neutrons. Those are made up of quarks, each of them of 3 quarks. So the way that the Standard Model works is that each of those particles has a set of so-called quantum numbers. And the quantum numbers define exactly what the properties of the particles are. Quantum numbers, one that you're probably familiar with, is the electric charge. Some of those particles have an electric charge. Sometimes it's negative, sometimes positive, sometimes it's 0. The particles can also have a spin. They have a property that's called the weak hypercharge. It's basically a more complicated version of the electric charge. The quarks also have a color, and so on and so forth. So there's this set of quantum numbers. And now the way that the Standard Model works is that you take all those quantum numbers for the particles, and then typically what you want to do is you want to calculate the results of some particle collision. And what you see in this picture here, this is what happens if you slam 2 protons into each other. So this is an image from Atlas at CERN. So the beams go into the screen, basically, and they run into each other, and then you create a lot of new particles, basically from the energy in the beams, and they go out and go into different kinds of detectors. And then what they do is they take the measurements in the detectors and they reconstruct where the particles came from and what kind of particles there were. And you compare this with predictions. So you have your data, and you make a calculation for what you expect with the Standard Model, and that's where the quantum numbers go in. And now the thing is, if there were any other quantum numbers that those particles had, then the results would just be different. Loosely speaking, it's because in quantum mechanics, everything that can happen does happen. So if there were more quantum numbers, then all those different possible values for the quantum numbers would also be produced, and there'd be more particles. and we don't see that. So if elementary particles had any other internal states in the quantum numbers, that just wouldn't agree with observation. So you can't just say, well, I believe that particles have an additional new property, which I call proto-consciousness. It doesn't really matter what you call it. There isn't any such property. So proto-consciousness can only exist if it has no physical properties whatsoever, in which case it does not explain any observations. So panpsychism is popular among some philosophers. So I should probably add that I'm not opposed to philosophy. In fact, I think physicists are not paying enough attention to philosophy. In some aspects, it'll be really, really important. For example, when it comes to the question, are those other universes real? This is really a question where you have to pay attention to what you actually mean by something being real. But the idea that particles have additional physical properties, whether you call these additional properties proto-consciousness or something else, is a statement about physics. So when philosophers start doing physics, then they actually have to pay attention to what the physics says. This is also, by the way, why I'm not a fan of the simulation hypothesis. This is another section in my new book. It suffers from the same problem. It makes big statements about the fundamental laws of nature without actually paying attention to what we know about the fundamental laws of nature. So do particles think? No. I think the overall story that I want to tell with my book is that I think science and religion aren't at war. There are a lot of people who try to play those two out against each other, but if you look at what's actually going on in the foundations of physics, then many of the ideas that physicists consider there, especially about the question how the universe began, they're basically extensions of some of those originally religious or spiritual ideas. They're just formulated in the form of mathematics. And there are many of those religious ideas which are still compatible with all we currently know. There are also some things that may forever remain unknown. I already said I believe that ultimately we probably won't be able to figure out how the universe began, because it seems to me that this is just a way that science is fundamentally limited, that we aren't allowed to make a story more complicated. Though that may not be wrong. Like there may have been a more complicated universe before ours. It's just that the way that science works, we would never be able to say whether it was actually correct. Another question to which we may never find an answer is if there's actually a theory of everything. So this isn't something which I talked about here in any length. Again, that's something that I talk about in my book. But to make a long story short, the problem is there will always remain the question for any theory, why this theory? We know that the universe has to be in some particular way. I mean, we know that it is some particular way and not any other. So we need a theory that agrees with what we observe. But then there will always be questions in this theory which we can only answer by saying, because it describes what we observe. So I think this is another way that science is fundamentally limited. Scientists don't always mind this gap. I think some of the examples that I gave you show this very clearly, that sometimes they stray over into a realm where actually the methods of science fail and they don't always notice. Okay, so this brings me back to my book, so I'm pretty much done. I hope you enjoyed this little talk. There are more questions in my book, and you can find more information on my website, existentialphysics.com. Thank you for your attention.
For more debates, talks and interviews, subscribe today to the Institute of Art and Ideas at IAI TV.